Welcome back, everyone. So let's talk about operators and their preference in Java. Uh, so the table that you're seeing right now, this table basically uh, explicitly exhibits that, what is the operator preference in the case of different types of operators that we have in Java. So the top row has the topmost row has highest preference, whereas as you go uh, downwards, you'll see that operator preference decreases. So postfix operators have the highest preference, whereas additive operators and then relational operators have even lower preference. So what this means is that in a single statement, you can have many operators, and while it may not make any sense, but to Java, if you're using multiple operators within a single statement, the order of preference decreases as we go from top to bottom in this table. There are some operators, or most of these operators are somewhat similar to what you have in Python or in C++, but for example, this instance of operator, I think we have something similar in Python, but just to be sure of what this operator does is basically compares if you have a string and you want to see which is which object, which class does this object belong to, you can simply say that, okay, whether this object, which is in this case is the name of the variable is name, whether is an instance of this string class or not. Okay, so this will return either true or false. So basically you can check any object belonging, whether or not that object is an instantiation of some particular class or not, using this instance of operator. Likewise, we have ternary operators, which have low, very low preference, but like this is something similar to if else statement, just a shorthand of writing, if this condition, which in this case is n1 is greater than n2, if this is true, then assign n1 to this max, otherwise assign n2 to this max. Okay, so if this condition is true, you'll assign this this whatever this expression is to your max, otherwise you'll assign the resultant of the second expression to your max variable. In terms of typecasting, this is also rather somewhat similar to C++. What you can have is basically, you can typecast your byte, for example, to short or to short to character or to float to a double. So this is perfectly okay, and this happens automatically. So you can take any data type which is represented in small number of bits and typecast it into some other data type which is represented with higher bit length. Okay, so that is called as widening casting. It happens automatically. So you have an integer, you can say that, okay, my some double is equal to that integer, which is perfectly valid. But the other way around is not so trivial. In fact, we don't know what happens. I think so. What happens in C++ is that, for example, if you typecast a double to a float, it will simply, remove those least significant 32 bits, given that a double is represented in 64 bits versus a float which is represented in 32 bits, for example. And for that, you have to, do this explicit assignment from a double to an integer using this, these round brackets. But you should be very careful doing that, because we don't know, like it may not be the case that, the double is typecasted into the so-called closest integer. We're not sure that how this conversion works. And never cast, I mean, so maybe casting from double to float makes sense in order to save memory, but like don't cast a float to a byte, for example. Right, so the next thing that I'd want to talk about is how to read inputs from your main Java program. So for that, we will need a scanner class, which is defined inside this java.utils package. And then what we can do is basically we can say that, okay, scanner just instantiate a new object of scanner and then pass, whatever your input input methodology is. So in this case, this I'm going to hit keyboard and feed my input using this terminal, but it may be the case that you can maybe access some virtual machine and port some input from there, so then you'll have different parameters. So I've simply defined my scanner. I'm simply saying that, okay, print this message, and then what happens is that we have different choices. So we can say that, okay, this input scanner, whether you want a floating point number as an input, whether you want a byte as an input, whether you want an integer as an input, or maybe you would want some the whole line, whatever you enter using your keyboard. So it depends upon which type of input do you want to typecast from this input scanner into your age variable. Okay, so right now I'm saying that, okay, just like the assumption is that I'm going to enter a floating point number. Okay, so it will automatically cast it into a float, but you can have different. So if you want, for example, to enter the whole line, you can use this next line method, which is a member of this input variable. And then we'll simply saying, okay, display that age, and then close the scanner. If I simply it says that I cannot close this. Okay. Okay, so you should not run this. You should run as run Java. So now it will run at terminal, and then it will ask my age. I will simply say that 5.64, whatever that means, and it will simply display it. If I run something else, if I, for example, I'm expecting a float, but if I simply type, some string, it will throw me an exception. Okay, and the type of exception is input mismatch exception, which we are going to see later. But you should be very careful about the type of input that you are expecting versus the type of input that you are actually inputting. Okay, if you want to have this type of input, then use this next line method, which will basically get your whole line, including white spaces and whatnot. Okay, and it will typecast it into a string. Right, so this is how you'll basically read inputs from your keyboard. Right, and so the last thing that we'll talk about is basically a particular type of control flow statements, which are if-else or conditionals. There are a couple of choices that we have, once, and this is once again, rather similar to the syntactical structure of C++. You can simply say that, okay, get some variables. If that variable is greater than some value, if there is some condition which is true, then assign some character to this variable character grade. Otherwise, else if some block of statement, else if some block of statement, and else by default the grade will be F. Okay, which is not good, I suppose. And then you can simply print out whatever your grade is. It also works somewhat similar in the case of switch case statements. You can say that, okay, I'm going to check value of month. If it's one, if it's if it's January, then break, if, or do something else, and if it's not, then do something else. And if it's neither of these 3-4 cases, then assign something or do something else, or print something. So the switch case statements and if else statements go hand in hand, and the syntactical structure is somewhat similar. Right, so this concludes our conditionals. In the next video we are going to see loops.